There are two other investment types that we want to take a look at: compound interest and compound continuous interest. They differ slightly from annual interest in that it takes and divides up the annual interest rate into even segments defined by how much it's compounding. So for instance, in this first example right here, it says this: we have a person investing $5,000 at 6%. Here's the key phrase: compounded monthly. What is the investment worth in 9 years? So here's literally what's happening. Instead of waiting till the end of the year to collect that 6%, what it's doing is it is breaking that 6% up into monthly percentages: 8, 9, 10, 11, 12. So it's literally taking that 6%. If you divide 6% by monthly, that's 12 months in a year, you literally get 0.5% each month. So that 0.5% each month adds up to the full 6%. However, here's the advantage. After earning 0.5% after the first month, you now have a higher principal value than the original $5,000 you started with, so that when you earn that second 0.5%, you're earning that 0.5% off of a bigger value than $5,000. And likewise, month to month, that 0.5% is earning off of a larger amount. So when you get to the end of the year, even though all the 0.5s add up to 6%, you're actually making more than 6% annually, because each month you're compounding on top of a bigger principal value from the month before, because you've already earned interest within that given year. So here's how this works. The equation for this is A equals P times 1 plus R divided by N to the power of N times T. So the key difference here compared to annual is this value of N. Now, we have monthly. Okay, so here's some typical values of N. N equals 1 if it's an annual interest rate. N equals 2 if you're compounding semi-annually. N equals 4 if you're compounding quarterly. That's 4 times per year, or every 3 months. N equals 12 if you're compounding monthly, 12 times per year. N equals 365 if you're compounding daily. And you can imagine that we could have even bigger N values if we were compounding hourly, or every minute or every second. Those N values get really big. Your N value is how many times you're compounding each year. In this example, we're compounding monthly, so N equals 12 is going to be what we're going to use. So we go back to this equation. We've got A equals P. P is our principal of starting 5,000 times 1 plus R. 6% as a decimal is 0.06, divided by our compound interval, which is 12, raised to the power of N, which we just said was 12, times T, which is 9. So we can go ahead and take this and plug it into our calculator, and we end up with 5,000 times 1 plus, now I'm going to do a second set of parentheses just to keep things safe, 0.06 divided by 12, close those parentheses off, to the power of 12 times 9. And I'm getting a value of $8,568.50. So investing $5,000 at 6% compounded monthly for 9 years produces an end investment value of $8,568.50. What I want you to notice is these values were the same values, the 5,000 principal, 6%, years that we did in one of our annual interest problems up here. In fact, we used it for this simple interest and annual interest. We already saw that annual interest was greater than simple interest. Right? Annual interest was greater than simple interest. Yet again, when we compound multiple times a month, compare this number, which just collected the 6% at the end of the year, 8,447, with what we just got, 8,568. So the more times you compound per year, the higher your value actually gets. So compounding, taking that percentage that you're earning and compounding it or splitting it up for multiple times each month or multiple times each year actually benefits you because your interest is building on itself, not just at the end of the year, but throughout the year. So let's try this one more time. Next example we have here is a person invests $4,500 at 9% compounded quarterly. What is the investment worth in 23 years? Okay, so A is equal to P times 1 plus R over N to the NT. So A is equal to P, principal value of $4,500, times 1 plus R. We have an interest rate of 9%, so that's 0.09, divided by N. This is compounded quarterly. Quarterly means 4 times a year, so our value of N is 4. And that raised to the power of N, which we just said is 4, times T, which it looks like T for us is 23 years. So, taking a look at that, we've got $4,500 times 1 plus 0.09 divided by 4 to the power of 4 times 23. I'm getting $34,852.80. So $34,852 is our investment value after 23 years by investing $4,500 at 9% compounded quarterly. So that's how compound interest works. Here's what someone did though. Someone asked the question, okay, so if compounding multiple times a year increases my end value, well, I want to compound as many times as possible. So they took the equation A equals P times 1 plus R over N to the N times T, and they asked themselves, what happens if we let N equal infinity? So we're not just compounding every minute, we're not just compounding every second, we are compounding literally every single moment. And what they found out was this, that this whole piece right here, if you set N equal to infinity, turns into E to the R. I'll explain what E is in just a moment. So this equation becomes A equals P times E to the RT. Now E is not a variable, E is a number. E is a number. In fact, if you take a look at your calculator, right here above the division sign, you'll see a little E value above the division sign. So if you hit your second button and then the division sign, it'll select that E. Okay? Then I'm going to hit enter. And the calculator knows that E is a number. It's a very special number. It's a number that this section converges on as N gets really, really big. Okay? So E is a very specific number. It's a very important number. Just like pi, right? Pi, it's such an important number that we gave it a letter name. E is a really important number, such an important number that we also gave it a variable name, E. Okay. So we're going to end up using that E in these next problems. Here's how this works. It says this, a person invests $5,000 at 6% compounded continuously. That's what this is called. When n equals infinity, it's called compound continuously, and we no longer use the compound equation, we use the compound continuously equation. It says this: what is the value of the investment after 9 years? So the compound continuously equation is A equals P times E to the RT. So that's A equals P. P is principal. Our principal is that $5,000 times E to the R. Well, our rate is 6%, so as a decimal, that's 0.06 times T. So it's interesting, this time our rate, our interest rate is in the exponent location rather than down being added to the number 1. Okay, so we got 5,000 times E to the 0.06 times 9. Okay, so with that calculator, let's take a look at what this becomes. This becomes 5,000. And what I'm going to do is I'm going to go second E to the power of 0.06 times 9. So I can literally just use that E value in my calculator, which is approximately 2.71, or 2.72, I should say. So hitting enter there, this value becomes $8,580.03. $8,580.03. So if you notice, again, we're using that $5,000, 6% for 9 years. And take a look at this value. It is yet even bigger than what we looked at when we compounded monthly up here. Here we got $8,568.50. Here we got $8,580.03. So if we compound continuously, the benefit is even better. Now, as you can see, though, compounding continuously, the benefit, the more you compound, the benefit slowly wears off. Where this compound continuously is the largest value possible for investing $5,000 at 6% for 9 years. This is the maximum amount that you could make if you are compounding, because there's no way to compound more than n equaling infinity continuously. So let's go ahead and take a look at this one more time just to drill home what we're actually doing. Okay, this last problem here says a person invests $9,200 at 7.5% compounded continuously. What is the value of the investment after 14 years? So again, the key phrase here is compound continuously. So compound continuously means I use A equals P times E to the RT. So A equals P. P is my principal initial value. That's $9,200. Okay. And we're going to multiply that by E to the R. My rate is 7.5%. Careful on this conversion. It's 0.075 times T. Well, we're investing for 14 years. So that's times 14. Okay, so letting our calculator crunch the numbers, that's 9,200 times E to the power of 0.075 times 14. We end up with a value of $26,290.39. So there we go. Taking $9,200, investing it for 14 years at 7.5% compounded continuously, produces $26,290.39. So these are the other two types of interest equations that we need to be aware of and how to use, and what equals what. So it's a compound equation and the compound continuously equation.